In the 1940s, Dr. Wilhelm Reich discovered an all-pervasive energy responsible for life that he called orgone energy. While studying its properties, he invented the Orgone Field Meter that he introduced in his book, The Cancer Biopathy. In Reich's original device, an induction coil is connected to a series of metal plates with a light bulb in between. When the device was activated, the light bulb would glow whenever a living orgone field approached the upper plate. The experimental life energy meter is a modern version of Reich's invention using advances in electronics to make it safe, compact, and portable. This device can be used to measure life energy in people, plants, food, liquids, objects, and generating devices. How to use the controls on the LM4. First, turn the on-off switch to the 1 position. That's ×1 on the gain range. Right now the needle is set for 0, but by adjusting the course you can move it to any point you want. It could be 50% typical use or 0. Now as we approach the blue square with the hand, you can see that the needle deflects. We can now increase the range to ×10 and adjust the 0 once again. Now you can see that the sensitivity is higher and it detects the body field at a closer point. If we now increase to the ×10 range, again we adjust the 0 for the optimal setting. We can now use the coarse and fine adjustments. Now you can see that the field of the body is detected at a much larger distance. If we now increase to the ×1000, and now we only need to adjust the fine just a little bit to get it to the right place. Once the fine is adjusted, then the body field is detected at an even further distance. Finally, the 2000 range, the most sensitive range on the meter. If we now approach the meter from considerable distance, we can measure the influence of the hand from over a foot away, over 30 centimeters. On the top of the LM4 there are 3 holes. One on the right has a red connector for external electrodes. The black one on the left is for connecting external electrodes such as the fluid probe, and a switch in the center which is for selecting which type of probe we want to use. So if right now it's to the right, then we're going to move it to the center position. That's for the external fluid probe, and if we push it to the left, that would be for the large plate electrode. So right now we're going to put it to the far right, and we're going to attach the tube electrode into the red socket. The glass tube electrode is in place. Now I'm going to bring my hand up to the glass tube and see that it deflects. The tube electrode can also be used inverted in fluid samples. The meter has a pop-up stand in the back which can be easily pulled out so the meter can be stood up, or it can be put back in and used flat on the surface. I'm going to show 2 different methods of measuring fluid samples using 2 dram vials with caps, which is about 8 milliliters roughly. The first method we'll call the absolute method, and that's where we measure the absolute strength of a particular fluid energy level. So in this case we have the meter set for ×10. So we're going to put a tap water sample onto the blue square, and you can see that the tap water reads about 41 approximately on the scale. Now if we remove the water sample and instead put a sample of milk, in this case it reads about 41, maybe 41.5, so there's not much of a difference, but the milk is a little bit higher. So this is what we call the absolute method. Now to see the difference more clearly, we can use what we call the relative method. So in the relative method, what we do is we'll increase the the range to 100. Well, we're going to put the water sample first, and we're going to adjust it now for, let's say, 50%. Make sure that the energy field of the body is away from the needle after you make the adjustment. Now we're going to put the milk sample there. And now you can see clearly the difference is 8. There's a difference of 8 times 100 on the absolute scale, which is a difference on the relative scale of 8% on the times 100. So we can clearly see the difference between milk and water, and this is repeatable. We can take the milk off and put the water back, and it reads 50% again. So the big advantage of the relative over the absolute is that we can measure small differences between different fluid samples so that we can see clearly what the differences are. Now we're going to test the large plate electrode. The meter is set for times 10. The top switch has been set into the large plate position. The meter is on the ground, and the large plate electrode is sitting on top of about 20 centimeters of white foam insulation to isolate it from the floor. In this way, the reading is about 35% on the times 10 range, and you can see that as I get off, the reading goes back down to 0. Okay, now testing a leaf from a plant. The soil is relatively dry, so this is the effect of the plant, not of the water in the plant. And you can see that once the plant is connected on times 1, it's giving a deflection of about 13%. This effect shows the coupling between the human body and the plant. So you can see right now that the reading is about 25%. It's on the times 2000 range. If I now approach the plant, you can see that the human body field increases the plant and the total energy reading up to about 35%. See, it's very clear, increase in the energy. And if I just bring my hand close to the unit, about the same distance, it doesn't affect the unit, but if I bring it up to the plant, it does.